Okay, so this is number 11 on page 756, chapter 12, chapter 12.4 actually. So the problem reads expected attendance. For an outdoor concert of the Los Angeles Philharmonic Orchestra at the Hollywood Bowl, concert organizers estimate that 14,000 people will attend if it is not raining. If it is raining, concert organizers estimate that 8,400 people will attend. On the day of the concert, meteorologists predict a 70% chance of rain. Determine the expected number of people at the concert. Okay, so let's look at this. So we want to make a probability table. Okay, so the way we do expectations when we have a list of probabilities and a list of events is we list the probabilities and we list the events. And so we're going to have two cases. We're going to have rain and no rain. Or is it sunny? Okay, so it's rain and no rain. Okay? So I'm using a blue marker pen. And usually I can write more nicely if I have my indelible marker on the paper. But I just can't seem to find it right now. So I'll do my best to write this stuff in a legible manner. But that says rain and no rain. Okay? Now, what happens? Now, our events are not going to be rain and no rain, right? Because really what our events is what happens when it rains. Well, when it rains, because we're interested in the expected number of people that be attend the events. Well, so those are going to be our two events. So the first event is going to be that we get 14,000 people if it is not raining. So I'm going to put for not raining, I'm going to put 14,000. It's a lot of people. And if it is raining, we're going to get 8,400 people. Okay? We're not done because to do expectations, we need to know the probability. So this is going to be my first event. My first event is going to be 8,400 people. And my second event is going to be 14,000 people. Well, it says that on the day of the concert, there's a 70% chance of rain. So that means, well, if it rains, we get 8,400 people. So that's a 70% chance. I'm just going to put 0.7, or you can write 70 over 100 is another way to write 70% or 0.7. 70% just means 70 divided by 100, which is 0.7. And if there's a 70% chance of getting 8,400 people, then which is rain, then no rain is the other case. Now there's only two cases, rain and no rain, or 8,400 people or 14,000 people. Okay, and these numbers are on average, they're not exact. Well, if there's 70% here, a 70% chance of this, and this is the only other possibility, then this has to be a 30% chance. Because whenever I do a probability table like this, they have to add up to 1 or 100 if I'm doing percents. 0.3 plus 0.7 is 1. Okay? Sometimes you might get a number slightly more than 1 or less than 1. That's because of rounding errors. Okay, so we're now ready to do the expectation. Now, the expectation, when I have a list of probabilities and a list of events, it's the weighted average of the events. Okay? It's kind of like if, one of your like when I'm calculating grades, or another one of your professors calculating grades, say tests are worth for a certain percentage of your grade, say it's 40%. They'll take your test average, multiply it by 0.4. So they're doing a weighted average to see this is your expected score in the class, considering all your homeworks and everything. So here we're doing something similar. We're doing, say, a weighted average of the possible events. So what we're going to do is we're going to do the expected number of people. I'm going to put in E, and for people I'm just going to put P. The expected number of people is going to equal to the first event times the probability of that event, which is going to be 8,400 times 0.7. And I'm going to do plus over here. The next event, which is 14,000 people times the probability of that event, which is 14,000 times 0.3. Okay? Now you can go ahead and do this out in your calculator if you like, or multiply it out. To me, it doesn't matter. And just give me 1 second here. And what you should get is going to be 10,080 people. If we do 8,400 times 0.7 plus 14,000 0.3, we should get 10,080 people. So this is what we expect so that's 10,080. So that's the number of people we expect at the event. Okay? And if you want to see a nice way to do those calculations, if you have Excel or if you have OpenOffice or something like that, you can just go into the spreadsheet and okay. Alright. So you just hit the equal sign to do a calculation, and we're going to do 8,400 times 0.7 plus 14,000 times 0.3 is equal to 10,080. Okay? So I hope this answers your question, and if you have any other questions, feel free to ask, and have a great day.